Okay, thank you. I'm going to invite all three of our speakers up into chairs at the table at the front and open the floor for questions and discussion with this group.
Thank you for three fascinating talks. I want to address a question to Alessandro. Really very, very interested in the idea of cooperative forms of data governance. And I know that a number of systems that GAFGH have been developing talk about doing automated governance systems, which we also need because you can't have a human data access committee for every access request, and there has to be some scalability. So I wonder, have you thought through some of the ways in which you might divide up perhaps some of the most sensitive decision-making around big data, health data, genomic data? I know it's something that we are thinking quite deeply or trying to think deeply about in our own work, and I wonder if it's something that you've addressed or have begun to think about.
Yeah, thank you very much. Yeah, actually, what is interesting to me about the cooperative model is that you can be a member, but you're not obliged to. So basically, the cooperative is a repository in which all data about myself can actually be aggregated. And I have the option of becoming a member, therefore acquiring a number of voting rights, and in this way I get to decide on data access conditions for my data, but also for the cooperative data more in general. But there are also lighter forms of participation. So a data subject can actually aggregate the data within the cooperative and just decide upfront what the conditions of access to his or her data are, and in this way he or she does not necessarily need to be in charge of decisions. I mean, I think that this is an important feature because we cannot be turning ourselves into data controllers 24/7. It's not feasible, it's not scalable, as you just said. But there are going to be people who are more concerned, who are more interested in having the tools to exercise their rights and to actually be more directly in charge, let's put it this way. So I think it's important to distinguish between what our individual entitlements in terms of being treated fairly, having your rights respected, having your data treated according to the law, and also, on the other hand, being able to be more directly in charge of those decisions. I think that this is basically what we're going to see in the future, a distinction between those who want to be more in charge and those who really still want to delegate to some extent.
So just to address this point, I think it in a more general way, would think of it from the point of view of my data and how I can actually control my data. At the same time, one can say that exactly because of the relationality that you said, that it all relates to other people and environment and so on, there's an aspect of responsibility to the data towards the community. So that means that if I have a certain amount of data that actually informs a particular condition and could help in the discovery of drugs or in whatever understanding of a disease, and because I actually am related in a large amount, let's say genome, 99.9% is identical, it's actually my responsibility to share it so that people can learn and contribute to the health improvement of myself, as well as the billions of people on the planet. And I don't see that happen. I see people discussing more about rights, but not obligation. I see, in some ways, contributing your genomics data and actually health data like vaccines. You're vaccinated not just to protect yourself, you have responsibility to people that are immunosuppressed, and you need to do it because of that too. What's the perspective of that? Of course, I don't expect you to give another talk because it opens the topic, but I would like a little bit of sort of comment on that, which is coming from a different direction. And not just you, but also from the data protection side too.
If I can just briefly, Manolis, this is a very spot-on question. Actually, our preliminary evidence shows that people who are willing to put their data into this kind of repositories and to get control on their data are also the ones that are more sensitive to the issues that you just very rightly raised. So actually, those who want to be in charge are those who want their data to be available. I know it might sound paradoxical at the beginning because, I mean, you want to be in charge because you want to control, but actually it's very much about making data available. And these patients from the MS courts, for example, they are actually enabling data aggregation that is the precondition for doing research, meaningful research on data. So I hope this answers partially your question.
Michaela, JP, do you want to add anything to that?
I would like to quickly enlarge from the GDPR side, because there's a lot of fear of what the GDPR is and is not, and some things we will see how the legislation will turn out in the member states. But the first approach is really to address it with common sense in saying what would I like to have in this setting to take place, and that the measurements and security are in place, are indeed that we can keep what we promise, basically. And ultimately, any thought about data protection is always, what do I want to protect it for? Do I want to protect it that nobody can use it and I hide it in the closet, or do I want to make it available in a specific setting? So now this is the perspective of the researcher. From the data subject perspective, this has to be made understandably clear that they can invoke the rights, but that they also know their limitations.
Very quickly. So Manolis, as usual, I fully agree with you. Of course, right? I mean, absolutely. So there is this notion of responsibility. And so what we are trying to do is to bridge the gap between the biomed community and the CS community. The CS community has a lot of tools to offer, but is too shy to talk with you guys. And so you have the problems, we have the solutions, but for some reason, the bridge still has to be built, and we are working on it. But it takes time because of the difference of you know, culture and backgrounds, etc. But we'll do it. We'll do it, I'm sure.
Hi, I wanted to ask you a question about data encryption and protection. What are some of the challenges? For example, I can see doing homomorphic encryption is almost cost prohibitive. It's very expensive. It's almost it might not be realistic for some organizations. So you know, to say the least. So what other challenges do you see in protecting the data, just enough to make it you know, usable enough, not to protect it, not to overprotect it, or make it unusable? Can you talk about some of the challenges in a little bit more depth? Thanks.
Sure. I mean, this is indeed a crucial question, right? And as much as blockchain has, or until recently, had a fantastic reputation, in the same way, homomorphic encryption, let's say, in a completely converse way, homomorphic encryption has a relatively bad reputation of being, you know, of having very poor performance, right? But things are changing because a lot of things have been optimized. Hardware has become way more powerful, and the parallelization also of computations can help. As a consequence, a number of things can be carried out nowadays with, you know, I've shown very briefly, well, the example, 400,000 patients, five locations, millions of variants, and the response time is in the order of, you know, the tens of seconds, right, for a query. So just very, very rough numbers, right? But the point is the following, is that by definition, what homomorphic encryption brings is the ability to let someone, typically a cloud provider, perform operations on encrypted data without ever being able to know the clear text, right? And I think this is really something that is needed in order to make progress and to entrust the cloud providers with the medical data. Otherwise, I mean, I don't think it's realistic to have all the medical data in clear text in the cloud. I mean, at some point, it becomes too risky, and even for the cloud providers, it's not a desirable situation, right? It's too much liability. So homomorphic encryption is exactly the solution for that. Yet, it has its limitation in the sense that, for example, nowadays what we are able to do is go up to, let's say, linear regression, logistic regression, and a bit more than that. If you want to do deep neural networks and things of that kind, then you need access to the clear text. So the solution is something that was already mentioned earlier today by other speakers, which is a tiered system in which you can make certain relatively simple operations in homomorphic space with relatively little control on the identity of the researcher who does that. However, if the researcher needs real access to the full data in clear text, then there should be a full vetting process, and then the researcher has to go to some bunker and be, and type somewhere and under much more, in a way more protected environment. So this is one solution. There is an alternative to homomorphic encryption, which is hardware-based solutions, a la Intel SGX, but it also has its own drawbacks. There is no silver bullet as usual.
Any other questions? Ewan? Oh, and then.
Got it. Perfect. I just want to say, though, that I think there's a huge amount of genetics, which is linear regression, logistic regression, and these other things. I think the subtlety is going to be all the kind of extra things that one tends to do in some of these large-scale analyses. So population control, covariates, knowing how to bring the covariates in, and these things. So when we tend to use genetics, the core algorithm tends to be quite simple, but there's quite a lot of complex data processing that happens between even well-formatted phenotypic data and genotypic data and the final linear model that you run. So my instinct is that our challenge, I mean, I'm so impressed by what's been going on in homomorphic encryption, but our challenge is going to be making it practical now, both computationally practical and data science practical in the sense of what one sends across.
Yeah, I echo your comment. I live in California, which is technically the far west, but I feel that I think it's an extreme solution to have the data always encrypted. I think that the more interesting aspect is revocability. You should be able to share the data as long as you trust the person that you're sharing it with, but you should be able to revoke the access to the data. That to me is essentially a compromise where you have interoperability as long as you need it, but you can respond to a breach, you can respond to a situation where there's a compromised entity, and you can revoke access to the entities. I've actually implemented a solution that implements the revocability of PHI information that we get from our customers. So I'll be very happy to kind of discuss it with you and see where you stand.
I mean, revocability can be indeed a solution, and it works fine if the data evolve quickly over time. However, for a genome, once the data is leaked, it's leaked, right, forever for a given individual. So it depends on the nature of the data, right? The fact, if you revoke because you don't trust an entity, because this entity has put your data on the web, well, c'est trop tard, tant pis, as we say in French, right? It's a pity, but so revoking in that case would be ineffective for it. So it depends on the kind of scenario you are considering.
So great talks. I just thought they were terrific. So it's the balance between, or the emphasis on consent and the public interest test. So I would be interested in your jurisdictions, how much emphasis you're putting on the public interest test as a justification to share unconsented data.
Unconsented data. Okay, so this is a question for you guys.
It couldn't be a tougher question, actually.
Thank you.
Thank you very much. Nice way to close the day. I don't know, it's very thorny. I think that in general, there are certain types of data that are considered to be public, so that can be shared without consent. So, for example, there is a lot of research, health-related research going on Twitter data. So typically you buy your data directly from Twitter. It's actually not for free, it's very expensive. And these are not supposed to be data that require consent because they are data that Twitter collects from open profiles. So in a sense, there is this idea that these data are already public and therefore are already available. Then, of course, they're not available to anybody but Twitter because researchers do not have the capacity to curate the data in a way that makes sense for them. I mean, I cannot go on Twitter and retrieve the data myself. It has to be done through Twitter. So in this case, I don't think that we will ever convince Twitter to ask consent whenever an access request comes from a research institution. It wouldn't make sense, of course. But the point is that in this kind of situations, maybe they need to update their terms of use notice, and they have to make sure that people actually have some meaningful understanding of this. Unfortunately, the evidence is that, I mean, evidence that we also have also from ourselves, the evidence is that we just click. We don't read the terms of use, we don't read privacy notices, we just click because we want to go where we are headed on the internet. So it's actually very difficult. There are studies going on as to what are ethical conditions for using this data, and I think that in the end the burden will be on ethics review committees. They will have to make the call as to whether or not a research project can proceed with unconsented data. I don't think we're ever gonna have reconsent from Twitter users, for example. It's just unfeasible, I think.
Well, to make it short, I can only agree with my colleague and maybe add that also the European Commission and the ethics unit is going in this direction in putting the burden to research ethics committees.
Okay, I think on that final word, we'll close the session. I'd like to ask all of you to thank again our three speakers for an interesting and very thought-provoking session today. So thank you very much.